All right, so 7.2 is going to be simplifying rational expressions part 2. So well, not really yesterday, you know what I mean. The last time we had a lesson together, we did multiplication and division. So today we're going to do what 2 other operations? Adding and subtracting. Good. So we're going to be adding and subtracting rational expressions today. So before we go into anything, we're just going to warm up. We're going to keep it simple here to get us into the group of what's going on. We're just going to start talking about fractions in general. Just a refresher. Now, can we add these 2 fractions together?
Yeah.
Because they have a? Exactly. They have a common denominator, so we can simply just add their numerators together and keep the denominator. So does everyone remember that concept? Okay. So we can add the numerators, keep the denominator. And that's because we have a common denominator. If we don't have a common denominator, we better find one, right? We have to find a common denominator. So, what about these 2? Do they have a common denominator? No. Do y'all remember the concept of an LCD? Least common denominator? Is it starting to ring a bell now? Okay. So the process with the least common denominator is we have to figure out what we can multiply each one of these by to get them to have a common denominator. So in this case, do these 2 numbers have any factors in common? Well, yeah, they have the x in common, good. Do they have any other factors, a numerical factor in common? Good, yeah, we would make it 12x, good. So since they don't have any factors in common, we just simply multiply the numbers together to get our common denominator. And to figure out what we multiply each one of these by, it's whatever would take us to get us to 12x. So what would I have to multiply the first fraction by? Good, 4. And remember, you have to do it on the top and the bottom. And what do you have to multiply the second fraction by? 3. So if we already put it over one big fraction, we can just multiply the tops. So what's 4 times 1?
4.
Good. And 5 times 3? 15. So now we have a common denominator, and we have two single numbers on the top, just numbers. So what can we do lastly here? Which gives us over 12x. And that's as simplified as it can be, right? So you're starting to remember these concepts a little bit? Okay. We're going to need to kind of rely on these as we go through the lesson. All right. Moving on to C. Bless you. What do you think the common denominator is here? It needs a y. They both have, okay, so here's how the thing that you want to look for first. They both have an x. We know that's going to be in the common denominator. Whatever they have in common will always be there. What does one of them have that the other one doesn't? A y. So we know the y has to be in there. So whatever they have in common only has to be written once. Whatever they don't have in common has to be written. And here, thank you, that scared me. And then these both have a, come on in. There you go. Thank you. All right. And what's our numerical common denominator? 4. Does everybody understand why it's 4? Because basically we can it has a factor. They can both go into 4. Okay. So now that we've done all of that, we figured out what our common denominator is. We can multiply this first fraction by what on the top and bottom? 2y. Whatever is in the common denominator that this one doesn't already have. Okay? And then do we have to multiply the second fraction by anything? No. So this is going to become 14y plus 5. 14y plus 5. And there's nothing else we can do. And that's that. Any questions on our warm-up? So this is only the warm-up. Okay. So let's move into our first set of problems or our rules here. So let me zoom out to talk about these. So, simplifying radical expressions when adding or subtracting. So the first thing you're going to do is factor the numerator and denominator, identify the restrictions, so basically where the denominator is 0, just like before, find the least common denominator, and multiply by the LCD, over the LCD, just like we did before, top and bottom, of course, and then simplify. So I always think things make a little more sense when you just can see them. So let me zoom in here. Alright, looking at this problem, first thing we want to do is identify our LCD. So, what letters do these both have in common? Good. So whenever they both have a letter, basically you're always going to take whatever the one with the highest exponent is, and that's always going to be your LCD. So it's going to be a to the third b squared. So the highest exponent that either one has is always going to be in your LCD. Okay? Now as for the numbers, see how this one has the b squared? So whatever one has the higher exponent on the letter has to go. Basically you take the highest exponent on the denominator, basically. Because a and b both go into a cubed and b squared. And then basically we check and see if our smaller number goes into this bigger number. Does our smaller number divide into our bigger number? Yeah. Yes. When that happens, that's bigger number will be your LCD. Okay? So basically you're looking for what can I multiply this first fraction by that will give me this as my denominator. Okay? 2, that's part of it. And what else? A to the, we don't need an A actually because we already have the A. And B, yep, you're right, it's just 2. You're right. I don't know what I'm talking about. And then on the next one, what do we need to multiply this one by? Do we have all the A's we need in the denominator? No, we still need to put in 2 more A's and 1 more B, don't we? So the goal is to get it to that same denominator. So at this stage, you can either write it as 2 separate fractions still, which we'll do kind of to get started. So 2 times 4 is 8. And then the denominator will be 2 times 5, which is 10 a cubed b squared plus 9 a squared b c. I usually like to put my variables in alphabetical order. And then the denominator will be 10 a cubed b squared. So our goal is to get it to that common LCD. Now, it doesn't matter if you do the restrictions at this stage or this stage, you just have to do them before you cancel anything. So let's look back to our original here. What values, looking at this, can A and B not be? Good. They can't be 0 because that would make my denominator 0. So now that I have my common denominator, I can just go ahead and add these together. So we got one big denominator because they have the same denominator, okay? And then we can just add our numerators. And there's not anything else we can do in this case because I can't factor the numerator or denominator. They're not factorable. You guys see that? So they're not factorable, so therefore, that's that. That's all we can do with it. So that's the main idea here.
Why would it not be 0?
Something like example 3 would not be 0 because it has a minus and plus at the bottom. Good question. Any other questions for me about this one? Okay. Let's try example 2 together. Alright, so let's identify our LCD. What? Oh, I thought somebody said something. First thing we're going to check. Does my smaller number divide evenly into my bigger number? Yes, that means part of my LCD will be the bigger number. Now, any variable in the denominator, take it with its biggest power that we can find. We got x to the third, and we got y squared. That's the easiest way to find your LCD. Does that make sense? Okay.
What?
Does your smaller number divide evenly into your bigger number? Yes. Therefore, that's part of your LCD, your bigger number. Then, look for in the denominator the highest exponent powers of your variables. That's what goes in your LCD. That's kind of the easiest way I can describe it. And then from here, we see what we can multiply each one by to get it to that LCD. So to get 2x to the third to my LCD, what would I have to do? Multiply it by 4y squared, wouldn't I have to? 4y squared. And then for the second one, what would I need to multiply the second fraction by to get that denominator to x cubed y squared? I have to multiply it by how many more x's? 2 more x's and no more y's, right? Because we already have enough y's. So then once we do that, we're going to multiply each one. I'll do the first one in pink, second one in blue. So that's going to be 12. My thing's lagging. 12.
Wait, why would it be 12?
Y cubed. Because 4 times 3.
Oh, I thought you were doing the denominator first.
No, I'm doing the numerator. And then the denominator would be 8x cubed y squared minus 5x squared z all over 8x cubed y squared. Just like that. And then once we have a common denominator, you can put them over one big fraction. And that would be your final answer because we can't factor anything out of the numerator, as you can see. Now, restrictions, like I said, in this case, it doesn't matter if we do it at the end or the beginning, but it is a good habit to do it at the beginning. So, what can't x be here? And y also can't be 0. Is it starting to make sense a little bit? Okay. My last class looked at me like it was too much. Okay. So this one, both of the denominators are binomials. Okay. So when neither of the denominators have any factors in common, which they don't. See how they don't have any factors in common? They're two separate, totally different factors. All you do for your LCD is simply multiply your two denominators together. So that's whenever your two denominators don't have any factors in common. You just multiply them together, and that will always be your LCD. So now that we have our LCD, we need to adjust our fractions.
So, no, because then it'd be like a trinomial, right? If you actually multiply it together.
It would, yeah. We're not going to multiply it together because in the end we might be able to cancel some stuff out. So you want to leave it factored as long as possible.
Okay.
So this one right here, we're going to multiply the top and bottom by x plus 2 because that's the factor this one doesn't have. And then which factor does the second fraction not have?
X minus 1.
The x minus 1. So the goal is to get them to have that same denominator. And when I do that, that's going to come out to be x times x plus 2 all over x plus 2 times x minus 1 plus 2 times, I should do it in pink or blue, 2 times x minus 1 all over x plus 2 times x minus 1, just like that. And then, since they have the common denominator now, it's going to be x plus 2 times x minus 1 all over. Now, in this case, we're actually going to factor or distribute this back out, okay? So I'm going to do that in all one step here. So I'm going to distribute this and rewrite it that way. So that's going to be x squared plus 2x, and this one's going to be plus 2x minus 2. Everybody see how I got that? I just distributed both of these. And then what do you notice about the numerator? I can combine like terms. So that's going to become x squared plus 4x minus 2 all over x plus 2 times x minus 1. Now, normally, if your numerator would have factored, you would factor it. But notice here, there are no factors of -2 that add up to +4. So the numerator is non-factorable. So for that reason, because it's not factorable, we leave it this way, okay? If it were to factor, we want to factor it. So this would be our final answer. Now we do need to identify our restrictions. So looking back at the original problem, what can't x be? Good, -2 or +1. Any questions about this one? All right, let's move on to example 4. So we have our two denominators. Now, are either of these denominators factorable? No. So neither of them have any common factors, so our LCD is simply the product of the two. Can't factor them, they don't have any common factors, so our LCD is just the product of the two. Moving on, we are now going to multiply these by what they're missing. So this one over here is missing what? 3y. And this one over here is missing, good, 2y minus 1, 2y minus 1. So this is going to become 3y squared all over 3y times 2y minus 1 minus 2y minus 1 all over 3y times 2y minus 1. Now that we have this situation where they have the same denominator, we can put them as one big fraction. So that's going to be 3y squared minus, and remember, if you're subtracting this whole binomial, you need to put your binomial in parentheses because we have to distribute that negative sign, right? So in order to simplify this, we have to distribute the negative sign right here, okay? So that's going to become 3y squared minus 2y plus 1 all over 3y times 2y minus 1. And this is our final answer. And I'll tell you why we didn't factor it. The reason we didn't factor the numerator is if you were to use AC method, you remember AC method, multiply here? There's no factors of 3 that add up to -2, so the numerator is non-factorable. Okay, so you would check and see if it would factor, and it simply does not. So for that reason, we can't factor it, that's our end result. Now, we have to go back to our original problem and find our restrictions. You can use the last one, but this is a little easier. So set each of these equal to 0, okay? Alright, what did you all get?
1.
Good, did you get 1/2 and 0? If you got 1/2 and 0, you're correct. Okay, 1/2 and 0. Because don't forget, 3y equals 0, that would be when y is 0. So, any questions about example 4? Okay, moving on then. Let's try example 5. So example 5 is one of these situations where we don't know what factors the denominator has in common because we are going to need to factor that denominator, right? So what I'm doing is I'm just rewriting the rest of the problem, and I'm just going to work on factoring my denominator here. Everybody see why that needs factoring? So what would my denominator factor into? Good, -2 and -1, because those are two numbers that multiply to give me +2, but add up to a -3. Now for our LCD. The first thing we look at is, do either of these fractions have any factors in common? They do, they have an x minus 1. That means that's going in your LCD, but it only needs to go in once. Okay, whatever they have in common only needs to go in the LCD just once. Now, what do they not have in common? Good. The x minus 2 also needs to go in the LCD. Whatever they don't have in common, they have to go in once. Now that's your LCD. I forgot to put one of these signs is wrong, isn't it? No, I did it right. Just kidding. Okay.
Wait, so where did you get x minus 2 from?
I have factored this. Factors of...
Okay.
So then from here, what would I need to multiply the first fraction by? Good, x minus 2. And that's going to be x times x minus 2. And once you get confident with this, you can just write it all as one big fraction. You don't need to write them separate and then put them together. If you feel comfortable, you can do it that way if you want to, but it's really up to you.
So is x minus 1 x minus 2 the factored version of that?
Yes, exactly. Yep, so if this denominator is like a trinomial, you need to factor that in order to find the LCD.
And it's numbers that multiply or add to -3 but multiply to +2.
Correct. So everybody with me on this step right here. What's our next step right here? Distribute. Good. That's going to come out to be x squared minus 2x plus 2x minus 1 all over this. And then what do you notice happens to my x terms? Good, they cancel out, which ultimately leaves me with x squared minus 1 all over x minus 1 times x minus 2. And what can this numerator factor into? It's the difference of what? You guys remember difference of squares? Plus 1 and x minus 1. So that's what we call the difference of squares. See how both of these numbers are perfect square root? You can take the perfect square root of them. Whenever that occurs, you can just take the square root of both numbers and you're going to have two factors. If you don't understand that method, you can also use placeholder method, where you put in a 0x and then factor as we normally would factor a trinomial. Either one will work to give you the right answer.
But then wouldn't x minus 1 cancel out?
Exactly. Yep. You're right. So yes, once you factor it, you'll notice that, see how these will cancel out now? This actually simplifies down to x plus 1 over x minus 2, which is our final answer. However, we forgot to find our restrictions. So do we use this equation to find our restrictions? Right here? No, we have to use the original one. So we're going to use our original factored version. Bless you. So we're going to use our original factored version. And when we look at that, we know x can't be what? 2 or 1. So remember, I often forget to find my restriction until the end, but you just have to know to go back to the original one, not the one that you just simplified. Because if you had, you would have only gotten one of the restrictions, not the other. Very important. So, do we have any questions so far? Is it making sense so far, the concept? Okay, good. Alright, first thing we're going to need to do is factor these denominators. As you can see, they are left unfactored. So what can I factor out of the first denominator? X. I can factor out an x, which leaves me with x times x minus 2. And then what about in the second denominator? What can I factor out? A 2. Okay. Now let's identify our LCD. What do you notice both of these factors have in common? X minus 2. That goes in once. And now, what does this green factor, or this green fraction, have that the other one doesn't in the denominator? It has an x. That has to go in once. And what does this one have that the other one doesn't have? 2. That has to go in your LCD as well. Yes, it came from factoring the denominators. And if they both have it, you only need to write it once in the LCD. So once you're at that stage, we have our LCD. So we have to figure out what we have to multiply each individual fraction by. So what do we need to multiply the first fraction by? Good, that's what it didn't have. And what about the second one? X. So this is all going to become 2 times x plus 2 minus x times x minus 2 all over 2x times x minus 2. Now we're going to have to distribute everything, okay? So we're going to distribute here, and then here and here as well. And that's going to come out to be 2x plus 4 minus x squared minus 2x all over 2x minus x minus 2, or times x minus 2. Why is it minus 2x? Because this x was negative. Yeah, see how we have a negative sign right here? So the x itself wasn't negative, but I multiplied it by the negative 1 because of this negative sign between the two fractions. Does that make sense? So then from here we want to cancel out anything I can cancel out. What can I cancel out in the numerator? Good. And that leaves me with 4 minus x squared, which is the difference of squares. Difference of 2 squares. What's the square root of 4? What's the square root of x squared? So that factors into that.
Why do you do it on the numerator? Never mind.
They factored, luckily for us. Now, can I cancel anything out?
X or 2x minus 2.
I can cancel these out, but when I do that, because they're in a different order and they're subtraction, I have to add in a negative sign on the top. Do you remember that? So that's going to be negative.
Why do you have to do that?
We did a long explanation on the last notes, but basically the easiest way I can tell you is because when you rearrange the order, subtraction is not a commutative property, right? Like, what's 7 minus 4? 3. And then what's 4 minus 7?
Negative 3.
See how when you flip the direction, it changes the sign?
Mm-hmm.
So that's why we have that negative come out, because we changed the direction of subtraction.
Okay.
Does that make sense? So this is our answer, but we have to go back and find our restrictions, right? So we always find our restrictions at the stage right here where we factored everything. Right here. So what can't we have for x?
2.
Good, we can't have 2. What else? 2 again, but what about this x? Means we can't have... Just a plain x means we can't have x equals 0. If you were to have taken that whole thing and set it equal to 0, you'd have x equals 0. You would have had x minus 2 equals 0. You would have had 2 equals 0, and then you would have had x minus 2 equals 0. This one gets rejected. These both give me x equals 2. And this top one just gives us x equals 0. So those are our restrictions. I should have done it at the very beginning to remind you, but yeah, you always have to go back to its original factored form. So any questions so far? Alright, we're going to take a 10-minute break before we go into the next section.